Exercise 78, question number 8. This particular one, because the area of the end is a regular hexagon, then actually we can work out the area of that end quite straightforwardly. The method is outlined on page 151 in the text, in the worked example there, but I'll have a go at showing you on here as well. If we look at this area, this end of the hexagon, we can actually draw in some lines here to divide the hexagon up, so into 6 equal parts like that. And if you think about those 6, because it's regular, those 6 equal parts, then each of these angles in the center here must be the same. So if we divide 360, which is the whole turn, by 6, we get 60 degrees in the middle. So we can draw a triangle. If we expand out one of these triangles to the side here, then that length there must be, that angle here must be 60 degrees. And because it's again a regular hexagon, these sides must be the same, which means that makes it an isosceles triangle. Therefore, these angles here must be the same. And so those angles add up to 120, half of 120 is 60. So in other words, all of these angles here are 60 degrees. So it's an equilateral triangle, which means all the sides are the same length. So therefore, this is 6 centimeters. So is this 6 centimeters, and so is 6 centimeters. So if we can find the area of this triangle, then we can find the total area of the end, because we've got 6 of these triangles in this end of the hexagon. So we find the area of the triangle and then multiply that by 6. How do we find the area of this triangle? Well, best way to do that is to drop a line down from the bottom, drop the perpendicular, as they say, from the apex down to the base, and then find the length of this side using Pythagoras. So if I know that the full length of the base is 6, then this is 3 centimeters either side. So I know the length of this side, and I know the length of the hypotenuse, so I can use Pythagoras to work out the height. Once I've got the height, then I can use area as a half base times perpendicular height to get the area of this triangle. And then, as I say, once I've got that area, multiply that by 6 and you've got the area of the end. And then to get the volume of the cylinder, of this regular hexagonal pyramid, the volume equals the area of the base times the height. So once I've got the area of that hexagon, I can multiply that by the height to get the volume.